In this chapter, let's discuss molecules. Lewis structures can show the bonds and lone pairs in molecules and ions without the consideration of molecular orbitals. Though molecular orbital theory is more accurate in predicting the energies, Lewis structures are easier to use and provide qualitatively correct results. Thus, Lewis structures are used to estimate molecular structures and chemical bonds. In Lewis structures, a pair of shared electrons is represented by a straight line connecting the two atoms. An unshared electron is represented by a dot. Electrons in a lone pair are drawn next to each other. Here, I use formaldehyde as an example to show you how to make a Lewis structure. First, determine how atoms are connected. There is a tendency that the atom with the lowest electronegativity locates at the center. However, first group atoms such as hydrogen cannot be at the center, as they cannot form more than one bonds. In formaldehyde, carbon has the lowest electronegativity except hydrogen, so it is at the center. Draw lines to connect the central atom and the surrounding atoms. Second, count the total number of valence electrons of the molecule. It is the sum of the number of valence electrons of all atoms. In the case of ion, the number is adjusted by its overall charge. In formaldehyde, each hydrogen atom has 1 electron. Carbon and oxygen atoms have 4 and 6 electrons in their valence shells respectively. The overall charge is 0. So, there are totally 12 valence electrons in a formaldehyde molecule. Third, subtract the number of electrons used for bonding from the total number of valence electrons. When counting the number of electrons in the bonds, they are supposed to be single bonds by default. So, each bond has 2 electrons. The result is the number of valence electrons not yet used. Assign them to the surrounding atoms, so that they comply the octet rule. Hydrogen needs only 2 electrons. Pay attention that the electrons in a bond account for the valence electrons of both atoms. In formaldehyde, 6 electrons are used in the bonds. There are 6 electrons left. Both hydrogen atoms have got 2 electrons in their valence shells from the bonds, so all the 6 remaining electrons are assigned to the oxygen atom. Now, the oxygen atom has 8 electrons in its valence shell. Fourth, if there are still some valence electrons left, they belong to the central atom. In formaldehyde, there's no remaining valence electrons, so we don't need to do this step. Fifth, if the central atom has not got 8 electrons, a lone pair of the surrounding atoms is used to create multiple bonds with the central atom. When one lone pair is shared with the central atom, its number of valence electrons is increased by 2. But the number of the valence electrons of the atom providing the lone pair does not change. This process is repeated until the central atom complies the octet rule. In formaldehyde, when one lone pair of oxygen atom is shared with the central carbon atom, the carbon atom has 8 electrons. Meanwhile, a double bond is created between carbon and oxygen atoms. Finally, write square brackets. Denote the total charge in the superscript if it is an ion. Formaldehyde is a molecule, so the charge does not need to be written. So far, the Lewis structure of formaldehyde is complete. Let's use nitrate ion as another example. Nitrogen is less electronegative than oxygen, so the nitrogen atom locates at the center. Nitrogen atom has 5 valence electrons. Oxygen atom has 6 valence electrons. The ion has 1 negative elementary charge. So, the total number of valence electrons is 24. There are 3 bonds, so there are 6 electrons in the bonds and 18 electrons left. They are assigned to 3 oxygen atoms. Each oxygen atom gets 6 electrons. Combining the 2 electrons in the bond, every oxygen atom has 8 electrons in its valence shell. There is no electron left for the central nitrogen atom. The central nitrogen atom has only 6 electrons so far, so a lone pair of oxygen atom is moved to be shared with the nitrogen atom. Now, the nitrogen atom has 8 electrons. Write the square bracket and the minus sign in the superscript for the 1 negative elementary charge. Thus, we have completed the Lewis structure of nitrate ion. Sometimes, we can draw multiple Lewis structures for a single molecule. We have to determine which one is the best. The best Lewis structure is the one that reproduces the real molecular structure. Formal charges are used to determine the best Lewis structures. The formal charge of an atom is the charge assigned to an atom in the molecule, assuming that the electrons in the bonds are shared equally between two atoms. It is calculated by the following equation, where V is the number of valence electrons of the neutral atom in isolation. N is the number of non-bonding valence electrons on this atom in the molecule. And B is the total number of electrons shared in bonds with other atoms in the molecule. Among all the Lewis structures of a molecule, the one whose atoms have the lowest absolute values of the formal charge is the best. We can use the Lewis structure of formaldehyde we drew just now as an example. The neutral hydrogen atom in isolation has one valence electron. In the Lewis structure, a hydrogen atom has no lone pair. It has a single bond. One of the two electrons in this bond is assigned to the hydrogen atom. Thus, the formal charges of both hydrogen atoms are 0. The neutral oxygen atom in isolation has 6 valence electrons. In the Lewis structure, the oxygen atom has 2 lone pairs. It has a double bond. 2 of the 4 electrons in this bond are assigned to the oxygen atom. Thus, the formal charge of the oxygen atom is 0. The neutral carbon atom in isolation has 4 valence electrons. In the Lewis structure, the carbon atom has no lone pair. It has a double bond and 2 single bonds. 4 of the 8 electrons in these bonds are assigned to the carbon atom. Thus, the formal charge of the carbon atom is 0. Since the formal charges of all the atoms are 0, this Lewis structure is the best we can find. We use sulfur trioxide as another example. The Lewis structure without considering the formal charge is shown below. In this Lewis structure, every atom has 8 electrons in its valence shell. The formal charges are written beside the atoms. This Lewis structure is not the best because the oxygen and sulfur atoms have positive and negative formal charges. To balance the formal charge of oxygen and sulfur atoms, we can move one lone pair from each oxygen atom to form a double bond with the sulfur atom. By doing this, the formal charges are all 0. However, you will find that the sulfur atom has 12 valence electrons. It contradicts with the octet rule. To solve this problem, we need to consider seriously the principle of octet rule and its limitations.